Data is one of the key components of any system. We cannot imagine a system without data. And to store data, we use database, and there are different types of databases available for us to use. So in this video, we are going to look at what is a database and what types of databases are available for us to use. Let's start with what is a database. Database is a place to store large amount of data, so we can store them, organize them, and we can also manipulate the data stored within the database. So that is what a database is. And the data itself can be a structured data. So this is like, for example, bank transaction or student information, or it could be semi-structured data. This is like, Facebook post and stuff like that, because not all posts will have similar structure. And the third one is called unstructured data. This is like, your video file, audio file and stuff like that. So these are the three different structure in which a data can come in. And in terms of the database itself, we have some common properties that most of the databases share. Let's look at them here. First, database provides fast retrieval of data, and it also provides a sophisticated querying option. So we'll be able to query the data as we like. The next property is called data integrity and relationship. So this is where we define what is the type of the data and what rule it should follow, what are the constraints, and how it relates to other data. Okay, so that is what this one is. Then the other one is security. All the databases provide security. This includes authentication, authorization, and encrypting the data and things like this. And another important one is transaction support and ACID property. Most of the database provides transaction support. So if one or more of the operations within the transaction fails, then you can roll back the whole transaction. And when we are using transaction, ACID is one of the key property which defines how transaction works. So ACID means atomicity, consistency, isolation, and durability. And almost all the databases provide a support to backup and restore data. So these are some of the common properties of databases that you see nowadays. Let's next move on to the types of databases that we have. Okay, so at a very high level, we have two types of databases. One is called relational database and another one is called NoSQL database, and sometimes this is referred to as schemaless database. And the expansion for NoSQL is not only SQL. Okay, so that is what it means. Let's start with relational database. Okay, relational database is developed on relational model, so it uses structured data. So we store structured data in relational database, and the structure itself uses tables, rows, and columns. So all the data will be defined in the form of tables, rows, and columns. And we can define relationship between tables. And we also use something called normalization to break down data into smaller tables to avoid repetition. So we'll be avoiding repetition and promoting integrity and consistency by using this normalization concept. And most of the relational databases comes with very good support for transaction and ACID properties. And almost all the relational databases uses structured query language, also known as SQL. But the downside of relational database is that it only provides limited support for horizontal scaling. So if you want to horizontally scale your database, then it is nearly impossible in most of the databases, and even if you manage to do it, the performance will not be as you expect. Some of the examples of relational databases are Microsoft SQL Server, Oracle Database, MySQL, Postgres, and databases like that. Okay, now let's move on to NoSQL databases. In NoSQL database, we'll be storing semi or unstructured data. Okay, so that is the flexibility of NoSQL database. We don't have to define a rigid structure. We'll be able to store semi and unstructured data, and the data itself can be of formats like key value, document, or graph, and there are many others actually. So these are the common ones. So the data itself can be key value, document, or graph, and this is suitable for large volume of data where you don't need to worry about strong data consistency. Okay, and normally NoSQL databases provide limited support for transaction and ACID properties. Nowadays it is improving, but the database itself was not designed for the use cases for relational database, so the support for transaction and ACID are not their priority. And we don't have any standardized way to query data from NoSQL. On the relational side, we have structured query language, but we don't have any such standardization on the NoSQL side, which means, the way you query data from database to database will differ. And this is one of the challenge. If you want to use multiple databases, there is no standardized way. And NoSQL databases comes with excellent support for horizontal scaling, because they are meant to handle large volume of data, and horizontal scaling is one of the key thing that is required to support large volume of data handling. So it supports horizontal scaling very well, and because it handles horizontal scaling, the strong consistency was lowered. Okay, so in order to enable support for horizontal scaling, they have compromised on the strong consistency, because if you have multiple nodes horizontally scaled, then if you go with strong consistency, then you will be losing performance. So they reduced the requirement for strong consistency in order to enable this horizontal scaling. Okay, so that is the key difference between relational databases and NoSQL databases. And some of the examples of NoSQL databases are MongoDB, Cosmos DB, Neo4j, and things like that. Okay. Next, let's look at some of the use cases of these systems. So we have relational database in one side and NoSQL database on the other side. Let's start with the relational database. You use a relational database when you favor integrity, relationship, and transactions. So this is for systems like bank transaction, where you want to have strong consistency and you want to have the data to be at the highest integrity. Okay, and you also want transaction support. So you'll go with relational database. And the other type of systems are things like e-commerce and order management, where the data integrity and relationship transaction, those kind of properties matters over scalability and other benefits offered by NoSQL databases. So for these type of systems, you will favor relational database. On the other hand, when you are using NoSQL database, you are going to favor scalability, flexibility, and fast access over integrity, relationship, and transactions. So this includes systems like high traffic websites and content management systems, for example, and even for logging, we could use NoSQL database. And one of the other common use cases is to use NoSQL database to store users' session information. Okay, so this is another example, and the choice of these databases depends on what you want for your application. So at a very, very high level, these are the compromises you'll be making. With the relational database, you favor integrity, relationship, and transaction, and with the NoSQL database, you favor scalability, flexibility, and fast access. Okay, so that is all I wanted to share about database and its types in this video. I hope this is useful. Thank you.